Hello and welcome to the second lecture on Geotechnical Engineering Comprehensive Learning. Myself Ankita, faculty from Department of Civil Engineering, Christ College of Engineering, Irinjalakuda. Coming to question number 1, the difference between maximum void ratio and minimum void ratio of a sand sample is 0.25. At E is equal to 0.38, the relative density of this sample is 68%. The void ratio at its loosest state is equal to, we have to find out the void ratio at its loosest state, and the options are given 0.45, 0.5, 0.55 and 0.6. So we should know what is the relative density of soil. It is also known as density index or degree of density of soil mass, denoted by ID, and it is given by the expression E max minus E divided by E max minus E minimum. So what are these three terms of void ratio? E max is the void ratio of the soil in its loosest state. So when the soil is very loose, the volume of voids by volume of solids, if you take the ratio, it will be maximum. And E minimum, it is a void ratio corresponding to the densest state of the soil. So the value will be minimum. And E is the natural void ratio. So let's see what are the particulars given in this question. What is the data given in this question? So here they have given E is equal to 0.38 and relative density is given as 68%. So if we express it as a ratio, it is 0.68, and also they have given the difference between maximum void ratio, which is E max, and minimum void ratio, that is E minimum. So the difference is given, so we can write E max minus E minimum is equal to 0.25. So these particulars are given, and if we substitute in this equation, we can find out the unknown. Which is the unknown that we need? It is E max, the void ratio of the soil in its loosest state. So we can find out E max in this manner by simple substitution, and we will get E max as 0.55, and the option C is the answer, 0.55. Question number 2. Pyknometer method for water content determination is more suitable for, and the options are clay, loess, silt and sand. So let's see how this pyknometer method is used, or what is the pyknometer method to determine the water content of a soil sample. So you can see here a pyknometer, and as a first step we'll take the empty weight of the pyknometer, and that can be denoted as W1, and after that we can take about 200 to 400 gram of some wet soil, which is our sample, and then we can fill it in this pyknometer. So the wet soil means there will be solid particles and water, and let the weight be W2. Then we shall fill this pyknometer with water, and somewhere up to the middle we can fill up with water, and we should constantly stir it in order to remove the entrapped air, and you can do it with a glass rod. And after that we'll continue filling it with water till it is filled flush with the hole in the conical cap. So you can see here a conical cap, and there is a hole at the top of this. So up to that we can fill it with water, and let's take the weight of that, and that we can denote it as W3. And after that we can empty the pyknometer, and we can wash the pyknometer thoroughly, and again we shall fill it with water flush with the top hole, and let the weight be W4. So with all these weights we can find out the water content of the soil sample by simply substituting in this equation, and the equation is given here. Just see, we require the value of G in order to find out the water content. So what is G? G is the specific gravity of the soil particles. So this method can be used only if the value of G is known to you. And also this method is quite suitable for coarse grained soils, because from coarse grained soils it is easy to remove the entrapped air. So this method is suitable for coarse grained soils. So let's see what is a coarse grained soil. So here is a table showing the different size range, showing the size range of fine grained and coarse grained soils. Under fine grained comes clay and silt, and the size is varying like this. It is shown here. Clay particles are less than 0.002 mm, like that it goes. And the sand, gravel, cobble and boulder are coming under coarse grained soils. So this method is suitable for coarse grained soils. So let's see in the options if there is any coarse grained soil given. So yes, sand is a coarse grained soil. Then option B, what is loess? Loess is a type of wind blown sediment, and mostly it is silt sized particle. It will be having silt sized particles. So silt is again fine grained soil. So in the given options, sand is the coarse grained soils. So our answer is option D, sand. Question number 3. In a wet soil mass, air occupies 1/6 of its volume and water occupies 1/3 of its volume. Then the void ratio of the soil is, and the options are 0.25, 0.5, 1 and 1.5. So let's remember these equations, these relations. Void ratio can be expressed as the ratio of volume of voids to the volume of solids. And the total volume is occupied, or it is having voids as well as solids. So the total volume can be written as volume of voids plus volume of solids. And what will be there in this void area? In the voids it can be either filled with air or water, or there may be both air and water. So we can write volume of voids as the sum of volume of air and volume of water. So these relations can be remembered. And now we shall come to the question. Here it is given, air is occupying 1/6 of its volume, 1/6 of the volume of the soil mass. So you can write volume of air as total volume divided by 6. And water is occupying 1/3 of the volume of the soil mass. That means you can write volume of water VW as total volume divided by 3. So what will be the volume of voids? It will be equal to V by 2. Now what is volume of solids then? We have to deduct this volume of voids from the total volume. So V minus VV will give you the volume of solids. It is again V by 2. Now we are asked to find out the void ratio of the soil, and void ratio is given by VV divided by Vs. VV is found, it is V by 2, and Vs is also found as same V by 2. So if we take the ratio, we will get void ratio as 1. So in our options, option C is 1, and our answer is option C. Question number 4. The void ratio of saturated soil is equal to dash of water content and specific gravity of solids. So you have to fill in the blanks. Let's see the options. Product, difference, sum, ratio. So there will be any relation connecting the void ratio to the water content and specific gravity of solids, and let's see if there is any such relation. So here comes an expression for porosity in terms of void ratio, and the void ratio can also be expressed in terms of porosity. Also there is another relation connecting this water content, specific gravity of solids, degree of saturation and void ratio. So all these three relations are given here. So with this it is enough. to answer this question, the void ratio of saturated soil is equal to. So the third expression can be referred to. And what are the terms in the equation? W, which is the water content, G, specific gravity of solids, and S, degree of saturation. So in the question they have mentioned it is a saturated soil. So for a saturated soil, it will be fully under the degree of saturation will be 100%. So if you express it as a ratio, it will be 100 by 100, that is equal to 1. So the value of S is equal to 1 for a saturated soil. And what if it is a perfectly dry soil? Dry soil in the sense there is no water in that. So the degree of saturation is 0. Okay. So in this question, now it is clear, it is equal to, void ratio is equal to the product of water content and specific gravity of solids. So our answer is option A, product. Now before moving to the next question, please take a pause. These are some other relationships, so you can refer this also for getting an idea about the dry unit weight, bulk unit weight, saturated unit weight and submerged unit weight, and how it is being connected to the different parameters like degree of saturation, specific gravity of solids, then void ratio and all. Coming to question number 5. A dry soil sample weighing 120 gram has a volume of 60 ml and specific gravity 2.6. Its void ratio is, and the options are 0.2, 0.3, 0.35 and 0.25. So we have to find out the void ratio, and what are the details given. It's a dry soil and the sample is weighing around 120 grams and the volume is 60 ml. The specific gravity, it is given 2.6. So we can use this expression in order to solve this problem. The dry density rho d is given by G rho w divided by 1 plus E. And rho d can be found here with the details given in the question, mass divided by volume, and it is mentioned here 120 divided by 60, and the unit is 2 grams per ml, and it is the same as 2 gram per cc, and rho w is the density of water, that is 1 gram per cc. Now you can substitute in this equation in order to find the void ratio. Void ratio E is unknown in this equation. G is already given, it is 2.6. So by simply substituting in this equation, you can find out the value of E here, and it is obtained as 0.3. And our option B is 0.3, hence our answer is option B. With this we come to an end of the second lecture. Thank you.